Alrighty. Here's one of the last videos for this section. And this definitely mirrors the format of a free response question. You're going to be given some information, whether in terms of graph, in terms of table like this one, or in terms of an equation. And then you're going to be asked several questions about it. So we start with example 5. Between 0 and t seconds, a large glass is being filled with water at the rate w prime of t, measured in ounces per second. Selected values for decreasing function w prime of t are given in the table above. Okay, so they give us a couple of pieces of information. They tell me what w prime of t measures. It measures the rate at which the large glass is being filled with water. It tells me the units of W prime, which is in ounces per second. And it also tells me that W prime is decreasing. And I can definitely see that from the values, but they're making it explicit that W prime is decreasing, at least in the first 6 seconds, from time 0 to time 6. Can you approximate the integral from 1 to 5 of W prime of t using a left Riemann sum? Okay, so we're going to use a left Riemann sum with 3 subintervals as indicated in the table above. So can we make 3 little sections from 1 to 5? Sure, from here to here, my delta t is 1. From here to here, my delta t is 2. From here to here, my delta t is 1. But I can create 3 subintervals. If we're using a left Riemann sum, then we're going to start with this one. And I'm going to write that my integral from 1 to 5 w prime of t dt is approximately, because this is an estimate, right? We're approximating. Let's see. Height times base. And plus height times base. And height times base, which equals 2.3 plus 3.4 plus 1.2. And let's see what we get there. 6.9. So this is our numerical answer to our estimate. Our integral is about 6.9. Now the question is, does it tell me to use units? It doesn't. So it's just looking for the approximation. But in part B, it says, using correct units, what does this symbol mean? What did we just find? Well, let's go back to the context and think. Are we accumulating different types of change, like positive and negative, or is it all the same type of change? And since this is talking about a glass being filled with water, then what we're going to get is an amount, a quantity that is the total amount, because it's not changing. The water is just coming in and in and in and in and in, right? It's not coming in and leaking. So total coming in between times 0 and times 6 seconds is going to be 6.9. What are the units? Well, we're supposed to multiply 0 ounces per second times seconds. Well, if we do that, I'm just left with ounces. So we can say this represents the total amount of water in ounces from time 1 to time 5. So 6.9 is 6.9 ounces, and that's a total amount of water that's been accumulated in the large glass in the first 5 seconds. It's not the first 5 seconds, I'm sorry. From time 1 to time 5, because this integral doesn't start at 0, it starts at 1. Last question. Is that answer an overestimate or an underestimate? By the way, I'm going to come back and I'm going to put ounces here. Is part A an overestimate or is it an underestimate? How do we know? Remember what we said. If the derivative is decreasing and we used a left, so going back to my table, if my derivative is decreasing and I used a left-sided rectangle approximation, then I'm going to have an overestimate. So I can say the answer is an overestimate because w prime of t is decreasing. And that's it. That's all we need. So be aware that these are the types of problems we're going to be working with soon. We'll be looking at some released problems, and we'll be able to calculate these definite integrals, at least approximate them using our approximation tools of left Riemann sum rectangle, right Riemann sum rectangle, midpoint Riemann sum rectangle, and trapezoid as the four main shapes that we're going to be using.